So, welcome everybody. 10 minutes left already, goddammit. Okay, so I want to try something before we start. So you know there's the Rugby World Cup right now happening in Japan. And I'm thinking like, this is a round room and I want people to be like at the right level of energy. So let's try to do a small wave. I'm just gonna point in there, people are gonna be standing up and just go around. Can we do this? Go. 1, 2, 3. There you go. Perfect. Cheers. So this is Stop Star Star Upload Language, the story of the FP ecosystem in Kotlin. So this is about one project. It's called Arrow. The website is ArrowKT. You have the logo, and there's somebody in the back even with a shirt and everything. So it's basically, we're at version 0.10, which is releasing this month, or has been released this month. And this is a project that has been running for 2.5 years, meaning that we're already stable. We have already been around for a while. We are not somebody's like pet project or side project. So when we came first to the Kotlin community, the first reaction that we had, like maybe 6 months into the project, and we went to one of the big conferences, we got approached by some of the leadership of the Kotlin language. And they just go like, guys, stop fucking up our language. It was like, okay. So how do we reach that point? What was the beginning of the project? And basically, it all started in a small community of Spanish developers that is called Find Cinnamon. Find Cinnamon is just a Slack group of Android developers that are Spaniards, where you can imagine the level of memes is like super high. And some people came and it's like, we come from the Scala community with a consultancy and we would like want people to learn a little bit about functional programming. And we started doing this like small prototype. And at some point we realized that the prototype was something that could be productized, that could be used in real environments. We only need a couple of tweaks. So at some point we decided to put more time, there was more volunteers, there were people from companies, there were people from like spare time that got together and got that initial version of the project. And it was called Category, and it had a beautiful logo. So after a few months, we realized there's another functional library that has already been had already been in Kotlin for a while. That was called Functional. So we got together, we had a chat. It's like, Mario, your library is great. We love it. We complement each other really well. Let's not compete. Let's not be Scala. And I know, right? And let's create a new library. Let's just drop all the branding. Let's create a new version. We're gonna call this Arrow. So the union of functional and functionality and category is called Arrow. So we've reached a point after a couple of years where we have like tens of apps using the library. We also have several backends. We know about people using this in the wild. We're talking banks, we're talking small startups, we're talking big companies. I cannot say names because copyright and whatever, but important people. There's already talking about this around the world. Like someday we showed up and it's like, hey, there's a guy in Romania giving a talk about Arrow. It's like, oh my God, that's amazing. How do we even get here? There are multiple books that have been written about it where 3K GitHub stars, but none of this is as important as validating us having consultancies. There are people already consulting on the library. So that's how you know you have real validation. People are making money out of it. So what's in it? Why do people want to do functional programming in Kotlin? So we have a bunch of really boring libraries. We have a whole prelude, we have an effect system or a version of an effect system, we have optics, and we have meta-programming utils. So we call this boring because it's basically something that you're used to work with every day, but in an environment such as mobile development, Android, very Java-y, very object-oriented, this whole thing feels like a whole new world. So we just ground it saying, hey, this is actually just regular stuff that any other language would use on an average day, and we're just trying to bring it to you, and we're trying to make your life easier. We're not trying to reach this like nirvana, ivory tower. So on top of this, we have that nirvana ivory tower thing that are the Incubator libraries. So in here, we have several other things that are within the Swarm repository that we're incubated that are either made by other people or they're a little bit too experimental or too abstract for the kind of domain that we're working on. So we have things about recursion schemes. We have the whole Monan template library. We have your functional filters, your writers, your class list. Really good job. Free, we have something that we call AQL, which is basically link you in Kotlin, which is a rebranding, basically a renaming of like, instead of functor, it's called mappable, so people understand what it does. We're trying to work on streams, and we're already people looking into how we can get persistent collections out of it. But so far, what we have seen that has worked really well for us, the biggest contribution that we have had to the project, is the result that end up with these tweets. I really appreciate the effort that Arrow team is doing in its docs. Thanks for bringing us the power of FP to Kotlin devs and Android dev, and the explanation of all the terms an object-oriented programmer needs to understand and apply them. I love ArrowKT documentation, well-organized, full of information, detailed explanation, videos. The validated example in ArrowKT is very slick. So it just took me 5 minutes scouting Twitter to find these things of people praising the library and the documentation. And this is one of my favorites. It's like, it would be nice to have a zoo of abstractions implemented in multiple languages with the quality of the ArrowKT docs. That's really validating. So the Arrow docs is basically a website. OK, it's cropped down. That's fine. It's basically a website where we can just have all the information about the library, but we also focus a lot on patterns, on how do you apply this functor filter, how do you apply this monad in context to get things that you want. So there are different important elements. I'm going to try to go into the actual page and see if we can get it live. Where are you? Oh, the other side, of course. Boom. So this is the live page. And basically, here on the side, you have a quick start that goes like the index, a list of libraries, what is important about your usual linters, blogs and presentations. The blogs and presentations is really nice because it's like everybody in the community, the version that they have used, and people can just see the videos. And then other projects. But on top of that, we have patterns, regular things. How do you functional error handling? How do you do dependency injection? The monad tutorial, of course, you want one, right? You have how you use free algebras and everything else. And then, boom, this monster. Like all the data types in the library, all the type classes in the library. And this isn't even like the API definition. This is literally just like a small description of how to use it with several examples. And on top of that, there's something really cool. The examples are executable. So if I go in here, and if this works, this was the part that scared me the most. You have a tuple of A1 and B1. I can just go and edit it and add 32 here, and it still works. And not only that, you have in the effects, you can even have concurrency. So you can create context with threads, and you can apply them with the effects system. So this has been massively successful for adoption. A lot of people are super happy that we did this initiative, and it has helped us really a lot. Something that you may have seen here at the bottom, there's a super accessible open chat window. OK, before we go into the chat, there's also search, and there's edit the documents. That's fairly standard these days. But everything just makes it so people can just come into the website. They know they can search for things, they can edit them if they feel there are some changes that need to require, and they can open a direct chat. And here's like a chat window. And I recorded this interaction because I really loved it. It's the first time that somebody comes, it's like, I'm confused by the syntax because I come from Haskell, and this Kotlin thing and this Java thing is completely alien to me. It's like, it's always the other way around. It's like, why are you running this Haskell-ish thing? It's like, oh, love this guy. There's also Bob. Bob is super helpful. So we're sitting in the public channels, ready to answer any questions. Not 24 hours, but as close as we can. So let's go a little bit of a rundown of the different libraries that we have. So the first one is Arrow Effects. Arrow Effects is sort of an effect system that is based on existing principles. So we looked into an existing paper for a language, and we saw if we could apply those same concepts within the Kotlin environment on top of coroutines. We also thought that it would be good to give people some syntax so they could work with regular IO combinators or any other effectful monad in a way that was meaningful for them. So for people, they know this as like for comprehensions or do notation. But for a Java developer, this is like a completely new world. So the system has three primitives. The first one is called fx, which is just a syntax. It's like your do. There's effect, which is what you use to wrap side effects or like non-total functions and everything else. And exclamation is being used to compute. So this looks a lot like F# when you do like let exclamation, and then you can continue your execution. And following the example that is on the website, you can have something that is my program, IOFX. Oh, can anybody see it? Ah, damn. Let me try it on the website. Yeah. Is it visible now? Perfect. There you go. So you have something that creates like a new thread, and the thread name is A. And then you have a function that is side effecty that is getting the current thread and is just printing the name to the screen. And then we say, OK, we're going to have a full program. We open the syntax, continue on a context, so continue on a thread, apply this effect of printing on the screen, continue on a different thread, and then print it on the screen again. So if I go and execute this with saying hello lambda, we can see that the first one is in the context A, which is the hello lambda one in here, and the second one is actually happening in the default dispatchers, which you're in Java, so you're in a fork join, in a JVM, so you're in a fork join pool. So basically, this whole syntax for an Android developer is like a complete mind blower. So on top of this, this has been stable. This has been working for a while. We want to build bifunctor I/O. So we're seeing that everybody is doing I/O of either. Either is not really good to use, so we want to write our own implementation of bifunctor. We also want to add what is called RIO in the Scala community, which is reader monad plus bifunctor I/O. So we can have like environment, error handling, and regular I/O in one single data type. And we want to build streams. So we want to be like a spec, same as FS2, for streams in the Kotlin land. So this is one of the exciting libraries. There's also Arrow Core, which is basically the prelude. The reason for the prelude to exist is because we have a really anemic standard library. The Kotlin compiler is really only a small wrapper over some of the Java constructs, regular lists, threads, and everything else. There's nothing really fancy about it. So we thought, OK, we can add an extension to this original library with our own set of data types. And you say, OK, Paco, but your language doesn't have higher-kinded types. How can you add something that is a data type? So we found this paper that is called lightweight higher-kinded polymorphism that is basically applied to our language. So what we did is define this simple interface, and the interface is parameterized on the container or the wrapper or the type constructor and the content. Simple as that. So if you have a data type, it's going to extend this kind of thing. The F is what is called a witness. So you're providing evidence that in your system there's a kind where that F is fulfilled. And this is just a phantom type. It's just a marker of a class that is not instantiable. So if you're talking about lists, you have class for list private constructor. You can have as many as you want for sequence, for option, for try, for ID, for set. So what you're trying to form actually is an isomorphism between this kind for option of A and the option of A. So if you can go in both directions, you're able to express higher-kinded types in a language that doesn't allow it. So how do you express this bidirectional relationship? The first direction is super easy. You say the class option of A actually inherits from for option of A. So simple subtyping is the way of doing one direction of the isomorphism. The other direction, we use extension functions. So an extension function basically says, it's like an implicit. It says, this is my context. This is what I'm going to apply to. And then you apply the function. So the context, this function is specialized at for option. And the result is actually the type. So extension functions are actually checked at compile time. So you cannot go and call fix for a type that is incorrect, and the IDE and the tooling is always going to give you the right type. And this is super important because people don't understand kinds. They just get something like, it's kind of for list, and like, what do I do with this? The IDE, you just press dot, and immediately the first thing that you see is fix, because that's the only operation that you are allowed in this context. So it goes and fixes back to you. And the implementation is super simple. It's just a downcast. So we're pretending that this is OK. This is the whole compromise of the whole system. We assume that the only implementation of this kind for option of A, you're only providing evidence for this one type. If there's a malicious agent in the system that implements kind for option for a list and then tries to use in a polymorphic context, sorry, you're a malicious agent, you get nothing. So the other part about the prelude is that with these kind of constructs, we can build type classes. We can build proper type classes on top of regular interfaces. So you can define inside an interface a function that is as simple as, for every f, an a and a b, container is your generic, is your type constructor. You can define a function from a to b, and then you can return a kind of f of b. So this is your regular functor, basically. And based on these principles, we were able to build the whole hierarchy. So we can go all the way down to effect. Asynchronous computing, just lazy operations. We have bracket, we have throw, monad error, all the way to invariant. We even have selective, which it's something that came out this year. And with all of this, we have this like super mega chart of all the implementations that we are providing in our prelude. So people don't have to even think about it. They just think, OK, I have a list. I have all these extension functions that actually come from this monad throw or applicative error or everything else, and they can operate with them. So we have rebuilt part of that feeling that you get in Scala or that you get in Haskell within Kotlin. How can we improve on this? We have a library for metaprogramming that is being built right now on top of compiler extensions that is called Arrow Meta. So we're at a stage where we are doing an early tinkering to figure out how we can do basic things like quasi-quoting. We can do things like hacking the type checker so he understands hierarchy in the types. We can even do a purity checker because we can say if this function is suspended, it allows side effect. If the function is not suspended, you're not allowed to have statements, or you're not allowed to do calls that return unit. So it's a really nice purity checker, but it's really simple to implement on top of this infrastructure. And then we can do implementation of coherent type class implementation. So we can have like global injection in the context of mobile development. And all of this is in the real world. So this is not only a project that we're doing for us. This is actually being used by some of the companies, and this is to address some of the pain points that we have found when working with this environment. So it's really early days. There's a lot of potential experiments that can be done in a language that is basically still in development or in evolution. So if people want to come in, there's plenty of space for you to work on. And we also have a good focus on industrial use cases. So we're trying to do things that are important to people. And with all of these like small pieces, we're able to create an ecosystem that we are trying to grow. So after we released the first versions of the library with some of these constructs, people in the community started building their own additional libraries. So we found really talented people that build these things like optics, like recursion scheme or free. And we immediately reached out to them and said, hey, we would like to incubate your project within the main repo. We want to give you the docs. We want to talk to people on the channels. You can be part of us. And over time, they also became maintainers of the main project, and they've been helping us for a long while. So a big thank you, for example, to Simon, to Aidan, Pablo Guardiola, and everybody else. And this is only like small libraries. We also have big projects that are based on the Arrow ecosystem, but are not necessarily part of an incubator. So there are things like Tut from Scala that basically is a snippet compiler for Kotlin projects, which is what is being used on the website right now. We have Helios, which is like Circe. It's our ESON, it's a JSON library. We have parser combinators. We have configuration languages. We even have our own testing library. What is the name? Property-based testing library, right? And this is like the real production use cases, people that wanted to have these kind of things in their Kotlin environment, whether it's in Android or in their backends. But on top of that, it also allows you to practice some of those concepts that you've learned that are usually only available in Haskell. Try them directly on your phone or on another environment. So I've been able to implement several papers. For example, the arrow effect system is based on the Frank language, and the paper is called Doobie Doobie Doo, I think. Weird. We have selective applicative functors. So we're actually the first library that was not Haskell that shipped selective applicative functors to 1 million devices. And I don't know if anybody's using them, but at least they're around. I personally experimented with build systems a la carte. I was able to create like an implementation that was almost there. It lacked existentials, but what can you do? I know, right? So, and we also have like a couple of like experimental things in the library. For example, we're defunctionalizing kind projections, which is just like some subclass casting bullshit, but it still works and it's type safe. So someday I'll write about this. It's going to be fun. So my whole point with this whole talk is that we have an environment that is ready for production, that has been used, that has been tested, that people from multiple environments are coming, but also this is a test bed, or this is a small place for us to play in. So if you want to join us, the barrier of entry is super low. We mentor people, we do one-on-ones, we are very available on the chats, we respond on Twitter, we have these videos, these talks, the books, everything on the documentation, because we're trying to grow this whole thing of functional programming in a place where we can just use it in a day-to-day work without needing to convince people that this is, this whole change of paradigm and everything else. So we have a really lovely community. We are now to up 180 contributors. We have our own chat in Gitter, and we have the Kotlin lang Slack. So if you want to take a picture, for me, just take a picture of this slide, and that's the one that is important for you. Everything else you can get afterwards. And basically, that's the end of my talk. I just want to say thank you very much for all the contributors, all the supporters, and everybody in the community for making this possible, and thank you for the Landale people to allow me to talk about it. Cheers.